Hey guys, this is Neha from Edureka, and today I will talk about big data applications. Now let's start the session and take a look at the topics to be covered in this session. First and foremost, I will tell you why do we need big data analytics and how it has enhanced the traditional data processing system. Next, I will talk about the various application domains that big data offers to the industries and its application use cases. And at the last, I will end the session by telling you about the scope of big data that will create a havoc in the near future. So let's get started with the very first topic, that is, why do we need big data analytics? When you talk about big data, is it just the size of the data that you're referring to? Absolutely not. It refers to the way we use the data, that is, the way how you gather, store, analyze, and process the data. Let me put up a question over here. Do you guys remember when was the last time you used a floppy or a CD drive to store your data? If I'm not wrong, it might be somewhere in 1990s, right? But now with time, the usage of floppy CD files have now become completely obsolete. So have you ever wondered about the reason? With the exponential growth of data, people started to store the data in relational database system. But with the advancements in internet and digitization, even that became insufficient. In order to overcome this, big data came into picture. And this big data provided new set of tools and technologies to store large amount of unstructured data. So how exactly it helped? Big data uses Hadoop Distribution File System to store enormous amount of unstructured data, and that helps us to reduce the cost for storage. And with the speed of memory analytics, big data enables us to make fast and better decisions. Not only that, but by gauging customer needs and satisfaction, it helped us to increase the availability of new products and services. I hope you guys understood the concept of big data and its importance. Now, let's move further and take a look at the various application domains that big data offers to the industries. As big data is growing at an exponential rate, various fields in day-to-day life are using big data to ease the process of storing and processing the data. So here I have listed few of the sectors that have been implementing big data like healthcare, education, e-commerce, government, IoT, and even in media and entertainment. Now let's look at each of these domains in depth. First, let's see how big data is used in healthcare industries. Guys, you all know that there is a huge amount of data generated in healthcare industries, and that data includes patient records, transactions, research data, and many more. So traditionally what happened? They failed to use the big data. Why? Because they had the limited ability to store and consolidate the data. Okay, I got a query from Piyush. He asks how big data analytics has improved healthcare industries. Thank you, Piyush, for this question. I'll explain you how. Big data analytics have improved the healthcare by providing personalized medicine and prescriptive analytics. Not only that, but also the researchers are mining the data to see what kind of treatments are more effective for particular conditions, and based on that, they identify the patterns that are related to drug side effects and then provide the solution that can help the patients and reduce the cost. And also on adoption of mHealth, eHealth, and wearable technologies, the volume of data is increasing, and that includes electronic health records data, CRM data, that is customer relationship management data, fitness trackers, historic patient, research data, purchase data, and many more. So now let me tell you why demographic data plays a vital role in healthcare industries. Here what we do is we map the healthcare data sets with the geographical data sets. And by doing that, it's possible to predict the disease that will escalate in specific areas. And based on these kind of predictions, it is very easy to strategize the diagnostics and then plan for stocking serums and vaccines. So this is how big data analytics has enhanced the healthcare industries. Now let's see how big data is used in real-world clinical analytics. Healthcare industries wanted to replace their legacy data warehousing solution with a data lake that could manage high volumes of data. In order for this, healthcare industries selected a company called CTS Tech, which is a specialist provider for healthcare, to build the solution. So CTS Tech designed the solution based on Cloudera Hadoop distribution, MapReduce, Spark streaming, and other Hadoop technologies. So here is how it works. Here we have diagnostic results and billing messages. This is nothing but the data source from where we get the data. And this data is injected into the data ingestion stream, wherein it undergoes Spark streaming and produce real-time data streams. And these real-time data streams are capable of processing 20,000 records per second. And they are then landed onto the Cloudera landing zone, wherein it undergoes deduplicating, cleansing, and standardization of the data. And once deduplicating, cleansing, and standardization of the data is done, it is then processed using MapReduce job and data processing stream. And this processed data is queried using Cloudera Impala. Now we populate and store the messages from Cloudera Impala into IBM Unified Data Model for Healthcare Organization. And from there we visualize the results and dashboard, and then we arrive at the solution. So this is how CTS Tech has used big data analytics and provided the solution in real-world clinical analytics. Now let's see how big data is used in education sector. Big data is revolutionizing the way we manage education sector. So how is it doing that? Here I have jotted down few of them. First, let me tell you how it is used in improving evaluation of student results. Guys, can you guess what is the only way to assess the performance of a student? The only measurement of the performance of a student is the answers that they write to assignments and exams, correct? So however, during his or her life, each student generates a unique data trail. And analyzing this data trail in real time, one can understand the individual behavior of students, and that helps to create an optimal learning environment for the students. And also, it is possible to monitor student actions such as how long they take to answer a question, which sources they use for exam preparation, which questions do they skip, and many more. So by considering all these factors, one can improve the evaluation of student results. Next, analyzing and creating the custom programs. You all know that we have lakhs of students from each and every universities, but customized programs for each and every individual student can be created. Everyone wondering how? That is possible with the help of a technique that is called as blended learning. Confused? What is this blended learning? It is very simple. It is just a combination of online and offline learning. And that gives the students the opportunity to follow the classes that they are interested in, and also they have the possibility for offline guidance by professors. Next, how big data helps us to reduce the dropout rates. As we have already discussed that it would help to improve the evaluation of student results, it's an obvious fact that the dropout rates at schools and colleges would also reduce. So what does educational institutions do? They use predictive analytics on all the data that is collected to give them insights on future student outcomes. And such kind of predictions will also help to run a scenario analysis on a course or a program before it is introduced into the curriculum. And this minimizes the need for trial and error. Next, now let's see how to compute the marks of students. Let me take an example here. Say, let me take attendees' names itself. Consider Priyat scores 90 marks in mathematics and 60 in geography, but Chaitra scores more in geography and less in mathematics. So what does big data analytics do? It helps to combine and analyze all the data of students, and based on that, importance can be given to each of the students who lack the scores, and also to give an insight about how to improve the performance. So these are the various ways where we use big data analytics in education sector. Now let's see a case study of IBM in education. It is used to monitor individual student performance, to prevent attrition from a course or a program. Next, to identify outlines for early intervention, to identify and develop effective instructional techniques, for testing and evaluation of curriculum. Now let's see how IBM has used big data analytics in learning analytics flow model. Here we capture instructional transactions as they occur. And these instructional transactions occur in a time-sensitive learning application. And this would be actually possible within a learning management or a course management system. And we use full capabilities of a learning management system and then generate a 15-week online course And this 15-week online course would generate thousands of transactions per second. And then we perform real-time analysis on these transactions, and that would be used to feed a learning analytics app. And to process all these data, we need a big database system. Without the help of analytics software, it is not possible to process the data in big database system. So we use Apache Spark for data processing, and then we analyze the transactions and establish a pattern, and then we arrive at decisions and course of action. And these decisions and course of action is then introduced into a curriculum or a course management system. So this is how IBM has made use of big data analytics in learning analytics flow model. Now let's see how big data is used in e-commerce industries. Big data is a game changer when it comes to retail and e-commerce. Retailers and e-commerce brands are using more of analytics to drive strategic action and offer better customer experience. So these are few of the usages. First, it is used to predict the trends. In order to predict the trends, we used a trend forecasting algorithm. And this trend forecasting algorithm combines the data from social media posts and web browsing habits to identify what is causing a buzz. And also to know which product is discussed more of online, we perform sentiment analysis task. And based on sentiment analysis and trend forecasting algorithm, it is very easy to predict the trends in the market. Next, optimize pricing. Big data enables retailers to identify best price for goods by tracking transactions, competitor, and cost of goods. And not only that, but retailers can also map the rise and fall of demand and match the pricing accordingly. Now, let's see how analytics has enhanced Amazon to forecast its demand. Analytics enables Amazon to predict the traffic on the website along with the possible conversion rate. And through the Amazon Web Services Cloud, the business has the flexibility to scale up in a real time. So as it can scale up in a real time, analytics enables Amazon to forecast its demand. Next, how one can create a personalized store. We have something called as fast web server technologies. And this fast web server technologies in combination with big data, businesses can generate dynamic websites that are filled with relevant products based on the historic behavior of a consumer and their personal preferences. So by grouping the personal preferences and the historic behavior of a consumer, one can create a personalized stores. Next, customer service. Customer service is available 24/7 in all the e-commerce industries. So big data analytics allows business to optimize this customer service. And how does it do? It compiles the data from previous online and offline transactions, social media information, purchase history, and many more. And by this, businesses can create a 360-degree view of the customer, and based on that, they provide enhanced customer experience. Next, sales generation. The main motto of all the e-commerce industries is to sell their goods and products. And retailers use big data to offer a personalized experience and prevent potential abandonment. So by this, we can have more number of sales generated. So these are few of the usages in e-commerce industries. Let's see a real-time use case in e-commerce. Here we have a user. User communicates with the e-commerce server portal in data stream. Here the data is collected from various sources, and that includes customer information, purchase history, reviews, and many more. And we have something called as input selection module to remove the noise from the data. So this input selection module is based on two factors. One, singular value decomposition. Second, dimensionality reduction. So what is the singular value decomposition? It is nothing but the technology that is used to speed up the recommendations with very fast online performance, and that requires just few simple arithmetic operations. So the data which is used to speed up the online performance is selected. Next, what is dimensionality reduction? Here we reduce a number of random variables under consideration that are not required in the data. So based on these two factors, the input selection module removes the noise from the data. So this noise-free data is fed as an input to HDFS input in Hadoop stream. And that input undergoes map-reduce job and produces HDFS output. The data that we get after applying map-reduce job is ready for analyzing. So in the data analytics stream, we use our tool to analyze the data, and from there we arrive at textual and graphical reports, and they are nothing but the reports that are used in prediction of trends, forecasting demand, and in sales generation. Now let's see how government sector has made use of big data analytics. In government use cases, the same data sets are often applied across multiple applications, and that requires multiple departments to work in collaboration. Okay, I got a query from Kalgi. She asks why big data analytics is needed in cybersecurity and intelligence. Kalgi, I'll surely tell you, but for now, let's see how it is used in traffic optimization. Big data helps to aggregate the real-time traffic data generated from road sensors, GPS device, and video cameras. The potential traffic problems in dense areas can be prevented by adjusting public transportation routes in real time. Kalgi, now I will tell you why it is used in cybersecurity and intelligence. You all know that the cyber attacks are increasing in volume and complexity, and that's becoming a tedious task for traditional analytics tools. But companies have to protect themselves against all kinds of attacks, and they also need to be able to detect and respond fast. So it's nothing but a PDR paradigm, that is prevent, detect, and respond. And in order to prevent, detect, and respond at a faster rate and quickly, there comes the big data analytics approach. And these challenges can be prevented and overcome with the help of big data analytics. For example, you can say it is used in enterprises to fight against cyber threats. I hope you got an idea about it, Kalgi. Now let's see how it is used in crime prediction and prevention. Police departments use advanced and real-time analytics to understand the criminal behavior, identify crime, and uncover location-based threats. Next, weather forecasting. The National Oceanic and Atmospheric Administration gathers every minute of every data from land, sea, and space-based sensors. And on a daily basis, National Oceanic and Atmospheric Administration uses big data to analyze and extract value from over 20 terabytes of data. Next, drug evaluation. The National Institute of Health uses big data technologies to access large amounts of data to evaluate drugs and treatment. Next, tax compliance. Big data applications can be used by tax organizations to analyze both unstructured and structured data from a variety of sources in order to identify suspicious behavior and multiple identities. This actually helps in tax fraud identification. So these are the various sectors where big data is used in government. Now, let's see how it is useful in e-government portal. So what is this e-government portal? It is an application that uses electronic communication devices, computer, and the internet to provide public services to citizens and the other people. So citizen or enterprise user use certain services via e-government portal. So these user requests are sent to big data infrastructure in order to be processed. And this big data infrastructure has a database that is not centralized, and hence it integrates with database of different ministries, government agencies, and local authorities. So both the databases are then deployed to cloud infrastructure, and in this solution we use cloud infrastructure to reduce the cost for storage. And here we have Hadoop framework to process the data. We run Pig and Hive queries on a Hadoop data platform and then store this data into HDFS, and then the response is sent back. So now let me tell you the workflow. User sends a request to the network using an appropriate interface. In this case, the appropriate interface is nothing but the web application that he interacts with. And the request is then forwarded to big data, and the processing happens using these technologies, and hence the response is sent back. So this is the internal working that happens, but for the user, when he communicates or interacts with the web application, he gets a response immediately. So this is how big data analytics is used in e-government portal. Now let's see how big data is used in IoT. Data extracted from Internet of Things devices provides a mapping of device interconnectivity. Such mappings have been used by various companies and governments to increase the efficiency. And IoT is also increasingly adopted as a means for gathering sensory data. And this sensory data is used in Medicare, industry, retail, vehicles, communication, and many more. So IoT represents the connected devices. But as there is an enormous amount of data, These devices are connected through IoT, and big data technologies is used to store and process this huge amount of data. Let's take a look at the smart city concept. The combination of IoT and big data is an unexplored research area that has brought new and interesting challenges for achieving the goals of future smart cities. You might have heard of Amsterdam, right? It is the pioneer in the concept of smart city. Now, you might be wondering how it has introduced the concept of smart city. Amsterdam has introduced the concept of smart city in smart government, smart health, smart retail, smart agriculture, and many more. I got one more query here, and this query is from Gino. He asks how Amsterdam has implemented the concept of smart city in smart home. Gino, I will explain you now. In case of smart city, they use a wearable technology. That is, any person in the home can wear the fitness band, that is a wearable technology. And the techies have programmed and integrated this smart thing in such a way that when the person wakes up, the lights will automatically turn on and the coffee machine starts to brew the coffee. And it is vice versa. When the person who is wearing the fitness band goes back to sleep, the light turns off. I hope you got an idea about it, Gino. Now let's move further. In this case, various smart applications exchange information using embedded sensor devices and other devices that are integrated with cloud computing infrastructure to generate large amounts of unstructured data. And these large amounts of unstructured data are collected and stored in a cloud or a data center using a distributed fault-tolerant database, that is NoSQL. And that is used to improve the single service or application and is shared among various devices. And we also have a programming model for processing large data sets with the parallel distributed algorithm, and that can be used for data analytics to obtain the value from the data. Here we have query engine like Hive and Mahout to query and structure the data. So this is how cloud and big data both are used in the smart city concept. Last but not the least, let's see how big data is helpful in media and entertainment. Various companies in the media and entertainment industries like publishers, broadcasters, cable companies, YouTubers are facing new business models for the way they create, market, and distribute their content. And that is happening because of the current consumer search and the requirement of accessing this content anywhere, anytime, and on any device. And big data provides actionable points of information about millions of individuals. And all these insights are gathered through various data mining activities. And big data applications benefits media and entertainment industry by media scheduling, ad targeting, content monetization, audience interest, customer churn prevention. So now let me tell you how to prevent a customer churn. Customer churn is a serious menace that media companies find almost impossible to tackle, and it has been found that at least 30% of the customers share their views through social media. And until big data arrived, combining and making sense of this user data was next to impossible. And with the advent of big data analytics, it is possible to know why customers subscribe and unsubscribe and what kind of programs they like, dislike with crystal clear clarity. So by analyzing all these factors, it is very easy to prevent the customer churn. Let's take a look at the Netflix example in big data. Netflix has tons of user data present in its database system. And this data is processed and analyzed, and we recognize the patterns for that. And here we have a new user request. And this user comes and search for a video in the Netflix search engine. And based on the video preferences and the user choice, we rank the video and also we give user experience. And then we continue to watch the trending video and we arrive at video similarity algorithm. So now let's see how the decision is made and the video ranking is being given. This is decision making Netflix data framework. Netflix uses Cassandra because it is highly scalable and strong on performance. Here we have Cassandra, that is a NoSQL database, and it is used by Netflix because it is very strong on performance. And we have Priam, that is a Cassandra helper tool, and also it is a Netflix cluster management tool that simplifies the Netflix administration, and it also uses API to query the Cassandra metrics. And next we have HDFS tables. The query data is stored in HDFS table in a table format. And we have 𝐒𝐧𝐥, that is a platform built by Netflix engineer to work on Hadoop MapReduce. And this 𝐒𝐴𝐺 converts the Cassandra HDFS tables into queryable format. And we have S3 JSON, that is a JavaScript object notation, and that is used to structure the query data. And hence, based on all these factors, the decision is made and the video ranking is being given. So if you go back, you continue to watch the trending video and you get the video similarity algorithm. So this is how Netflix has used big data analytics. Now let's move further and see the scope of big data that will create a havoc in the near future. First, 6x growth. It's obvious fact, the amount of data that will be generated in the next 5 years will be 6x times more than that what was generated in the past 5 years. So imagine we'll be having huge amount of data. And not only that, but also the Hadoop adoption is growing at 29 times more than that of US GDP. Next, an open source supernova. Let me bring out the comparison here. In 1998, only 10% of the companies used to use open source networks, and that gradually increased to 50% in 2011. And now, 78% of the companies use open source softwares, and in the next years, entire 100% of the companies use open source softwares. And these advancements is because of the growth of big data in the market. Next, why it is termed as meteoric innovation. You all know that in 2008, there were more things connected to the internet than people. And now, IoT devices represent over 6.48 billion devices connected. And in 2020, the IoT market will connect to over 21 billion devices. And by 2030, self-driving cars will rule the roads of the world. And that is why it is termed as a meteoric innovation. The next, 3x increase in profit. Based on the above three terms, that is 6x growth, open source softwares, meteoric innovation, it is an obvious fact that as the technologies evolve, the growth will be evolved. And that leads to 3x increase in profit rate as well. So in the next few years, the profit rate will tend to increase to 3x times more than that what it is there in today's world. So this is why we say that big data is going to create a havoc in the near future. So that's all for today, and I hope you guys enjoyed the session and also it added value to your knowledge. Thank you everyone for attending the session and happy learning.